Alright, you're welcome to today's class. Today we'll be looking at vectors, basically resolution of vectors, okay? But before we go into resolution of vectors, let's talk about vectors, okay? What are vectors? Vectors are physical quantities that possess both magnitude or what we call value, okay? Like 1, 2, 3, 4, 5, okay? These are values. And another word we use for that value is magnitude. So vectors contains or vectors possess magnitude and they have direction. So when they ask you what are vectors, vectors are physical quantities that possess both magnitude and direction. And it's as simple as that. Now, I've said two things, okay? I've said that they have magnitude, okay? And I said that they have direction. Okay, for us to understand these two things that I mentioned, okay, I want to consider two basic fundamental quantities. So, the first one I'll be considering is distance. Distance. So, if I have distance here, okay, let's consider 2 points, and this is point A, and the other is point B. Okay, now for those 2 points, let's assume somebody is actually standing here. So if the person is asked to use 10 centimeter, let's assume the person was not given a direction, just move 10 centimeter. Of course, the person can decide to move to the top here, 10 centimeter to the top. The person can also decide to move here. The person can also decide, or the person move this way, which means that a direction was not given and the person can move anyhow the person wants. Okay, let's assume that the person at point A is moving through this distance, moving from here to this place, and this place covers 10 centimeter. You see that 10 centimeter is called a magnitude, is just of a value or what you call magnitude, and it's as simple as that. Now let's look at case 2 where we have displacement. Okay, now for displacement we have the same 2 points, point A and B. So we have a point here and we have another point. The first point is point A and the second is point B. So we have somebody here, okay, maybe a soldier or so, and the commander is giving the person a directive or a direction now to move. But the person is saying move 10 centimeter due east. Okay, of course we know that if I draw my cardinal point here, I'm going to have north here, I'm going to have south. Okay, south, this point A. So if I have south, I'm going to have west, and I'm going to have east here. So the person giving the direction can just say, or giving the command can just say move 10 centimeter due east, right? So when the person said due east, it means that this soldier here or the person here cannot move this way, neither can the person move to the north or the south. The person must obey that command. And if the person will move, the person is going to move in this direction towards B. And it's as simple as that. But the distance the person has covered is still 10 centimeters, just like this person. But just that this person covered the distance in a specified direction based on the command. But this person covered the distance based on his or her own will. Do you understand? So in this sense, we can write due east for this person. Okay, so what's the difference between distance and displacement? Distance is talking about just covering a gap between 2 points, while displacement is talking about covering a gap between 2 points still, but in respect to a particular direction. And it's as simple as that. Do you understand? So I have magnitude and I have the direction for this, but here I have only magnitude. So which means that whenever you talk about vector, what you think about is you think about the magnitude, then you think about the direction. Now, these two basic things that I wrote here, or basic physical quantities rather, that I wrote here, have implication on the formulas we write in physics. Okay, so for instance, if I write velocity, okay, the formula for velocity is actually displacement, right? Displacement over time. Displacement over time. Now, when you observe very well, displacement is a vector quantity as we've established here, right? Because it is a vector quantity and this one is a scalar quantity. Time is a scalar quantity. Time does not move in respect to whether north, south, west, or east, right? How does time work? Time just keep rotating clockwise, or if set anti-clockwise, it moves anti-clockwise. But the point is not going towards a particular direction. It's just undergoing a rotation around its own axis, right? So it's a scalar quantity in that sense. But for displacement requires direction, right? So in that sense, what do we say? We'll say that this is a vector quantity, and when vector quantity is divided by a scalar, right, or multiplied by a scalar, what it yields is actually a vector quantity, which means that velocity is a vector quantity. The same thing applicable to acceleration. Okay, so if I also deal with acceleration, I'm still saying acceleration, the formula is velocity over time taken. Okay, because it is velocity over time, velocity has been established to be a vector quantity already. Hence, velocity against time will yield a vector quantity. In another way, we can say that because velocity has displacement in it, and displacements happen to be fundamental for almost all vector quantity. Hence, we can say that acceleration, velocity is a vector quantity and acceleration is a vector quantity. So if I also talk about force, force is equals to mass, okay, times acceleration. All right, acceleration. Mass is a scalar quantity because it's just a quantity of a substance. Do you understand? It's just a value to tell, oh, this is 10 kilogram, this is 10 gram, right? It does not have direction. So, but acceleration has a direction, okay? You accelerate towards the north, east, or south, okay? In that sense, since they are being multiplied together, and this is a scalar, this is a vector, what it's yield is actually a vector quantity, which is actually force, right? And it's as simple as that. But there are some exception, okay? For pressure, for instance, pressure is an exception. All right. Why did I say pressure is an exception? The formula for pressure is actually force, okay, over force over area. Yeah. Okay. So we have force. Force is actually a vector quantity as established, and area is a scalar quantity because area does not deal with direction. It's just length times breadth. Do you understand? So in this sense, how can we establish that? This, of course, this is a vector and this is a scalar. So what it's supposed to yield normal is a vector quantity, okay? So, but it won't yield that, right? Because when pressure is acted upon a substance, okay, the pressure move in all directions as far as that substance that you're mounting the pressure on is concerned. So it has no particular direction that it's moving to. Do you understand? So for you to deal with quantities like pressure, you have to have an understanding of how pressure moves, and that is actually in respect to Pascal's principle, which says that when a force or when a pressure is mounted on a confined liquid, the pressure is distributed undiminished, right, or unchanged, right, throughout the fluid. In that sense, it means that pressure moves in different directions. It moves in all directions. Okay, that's that for pressure. Let's look at power too. Okay, power is equals to work done. Okay, work done over time. Of course, we know that time is a scalar quantity, but what of work done? Okay, work done is actually force times distance or force times displacement. Now, but work generally is in joules. That's the unit of work. But work itself is actually a scalar quantity, and this is a scalar quantity. When two scalar meets, what happens is that they yield a scalar product. Okay, so that's power. I think this helps. But majorly, what I am focusing on today is actually resolution of forces. Okay, now for us to understand the concept of resolution, we have to understand also that, or we have to understand first that resolution is talking about axes, the axes we have on the coordinates. Okay, take for instance, we have I have here is y-axis. Of course, I know that this x-axis, this y-axis, right? But there's one other axis which is the z-axis. Okay, right? These are the three major axes that we have in respect to resolution. Okay, now which one do we have to resolve? But before we go into resolution totally, let me quickly show you something that I think or I know that would be helpful during the journey of resolution of forces. All right, first we need to understand how the Cartesian works, okay? So we have this and this, okay? Right? This is your y-axis, this is your x-axis. So we want to see why this is positive y and why this is positive x. Why do we usually say this is negative y? Why do we usually say this is negative x? Okay, of course, that's how we've been plotting our graphs since primary school, and we need to know this now how it all goes. Okay, so note that this place, okay, this point here is actually 0 degree. Okay, so I'm starting from here. Now from here to this place is actually 90 degrees. Here is 90, here is 90. So for each box we have 90, 90, 90, which makes it 360. So there is a point here, and angle at the point is actually equals to 360. So from here, from 0 to this place, it would actually be 90 degrees. Okay, so this still remains your y-axis. Now from here to this place will actually be your 270 degree. All right, so and from here to this place, okay, no, this will be 180 degrees, and from here to this place will be your 270 degrees, and this can still be your 360 degrees if you want to. So it's either it is 0 degree or 360 degrees. Now note that for you to get the values here, you have to use cos, okay? Cos anything you're having, right? And this would work as sine. Y-axis work as sine anything you're having, just like SOHCAHTOA, right? Okay, so what do we have? So I'm pressing cos 0. So what I'm using here is either you press cos 0 or cos 360. Okay, so I'm pressing cos 0. Cos 0 happens to be +1, which means that the reason this place is this particular part of the Cartesian is positive x is because the answer is +1. So if you press cos 0 or you press cos 360, it will give you +1, which means that this place must be positive, right? So we are trying the next one, which is sine 90 degrees. So if I press sine 90, what am I going to have? I'm still going to have +1 on my calculator. I'm still going to have +1. All right, so press cos 180 degrees. Cos 180, you're getting -1. So which means that this x-axis here, right, I'm using cos for x-axis, sine for y-axis. This x-axis here is going to be negative x. Now, if I come here, what am I going to get? I'm going to get sine, because I'm still dealing with y-axis here, right? Sine 270 degrees, okay? And that is giving me -1, which means that we are always correct when we write this place as negative y. And so that is why whenever you start from here, you say this place is negative, this place is positive, this is positive, this is negative, and that's the reason, okay? But that's not really where we're going. But these ones would actually have an implication on the resolution of forces as we move by. So, and I don't have to teach that while dealing with resolution of forces. So, how do we resolve force, or when do we have to resolve a force? Okay, now I'm taking off all of this, right? Since we've known that already, so I'm taking them off so I can use the diagram for a new concept entirely. Okay, so this is what I have now. Now I have this guy here, okay, this line, positive y and x. So this is my y-axis. Now I know I can confidently write that this is my plus y, this is my negative y, this is my negative x, and the likes of it. Now, if a force or a vector, don't let me say a force, because force is a vector, okay? Sometimes they can give you as velocity, okay? Let's assume I have a velocity here or a force here. Preferably, I want to use force, okay? So I have 3 newtons, okay? And I have another force here, let's say 5 newtons. And I have another force here. But this force, this time, is falling in between x and y, which means that the force is actually a z, is actually falling on a z-axis, because this is y, this is x, and this is your z. So this force, let's say, is is 2 newtons, okay? 2 newtons, this force is actually falling on the z-axis. So now, which one are you going to resolve in the course of undergoing resolution of forces? You don't have to resolve this, okay? This value will be presented as it is. You don't have to resolve this, okay? This value will be presented as it is. But this force here, okay, need to be resolved because it's not falling on x or on y purely. Does that make sense? And for it not to be falling on the normal configuration, like the normal how am I going to put it? The original axis that we are supposed to have, which is x and y. That's what we deal with. Okay. Now, if anything is falling on z-axis, you have to resolve it. You have to break it. That's why it is called resolve. Okay. You have to break it into two. And how do you break it? You have to break it towards x and not or. Okay. You must break it towards x and towards y, which means that this force must have a component in x and it must also have a component in y-axis. And it's as simple as that. Do you understand? But then, if you're breaking it always, or you're always resolving it in respect to an angle. So which means that an angle must be given here, or the angle is placed here. When the angle is placed here, you're fine. But when the angle is placed on y-axis, I'll tell you what to do in the course of the lecture.